At its core, a bullet is a projectile. It's a small piece of metal designed to be fired from a gun. Think of it as the part that does the traveling. When you hear a loud bang from a firearm, that's the sound of a controlled explosion pushing the bullet out of the barrel at incredible speed. Its main job is to hit a target far away. This simple idea changed everything, from how people hunted for food to how they defended themselves. The bullet made distance less of an obstacle, which was a huge leap in technology for its time. Before modern factories existed, if you owned a firearm, you were often your own ammunition supplier. You couldn't just go to a store and buy a box of bullets that perfectly fit your gun. People needed bullets for very practical reasons. They used them for hunting animals like deer or bison to feed their families. They also used them for protection on the frontier where help could be very far away. Making your own bullets was a necessary skill, as essential as knowing how to build a fire or find clean water. It was a fundamental part of self-reliance in a world that demanded it. The need for bullets drove a lot of innovation. Early firearms were not standardized. This means that a gun made by one blacksmith might be slightly different from one made by another, even if they looked similar. The barrel of each gun had its own unique diameter. Because of this, you needed to make bullets that were the perfect size for your specific firearm. A bullet that was too small would rattle down the barrel and be inaccurate. One that was too big simply wouldn't fit at all. This is why handcrafting was not just a choice, it was an absolute necessity for anyone who relied on a gun. So the story of bullets begins with a simple need, the need to project force over a distance for survival and security. It wasn't about complex machinery or mass production yet. It was about individual people, with their own hands and simple tools, creating the very things they depended on. Each bullet was a small project, a testament to the resourcefulness of the person who made it. This hands-on approach created a direct connection between the user and their tool, a relationship we don't often see today in our world of mass-produced goods. It was a slow, deliberate process born out of pure necessity. So, how did they actually do it? The process of making bullets by hand was surprisingly straightforward, but it required care and attention. The primary ingredient was lead. Lead was a great choice because it's a very soft metal and, more importantly, it has a low melting point. You didn't need a giant industrial furnace to work with it. A simple fire in a fireplace or a campfire was hot enough. People would gather scrap lead from any source they could find, old pipes, broken fishing weights or sheets of roofing material, and place it into a small iron pot or ladle to melt over the flames. Once the lead was melted into a silvery liquid pool, the next crucial tool came into play, the bullet mold. A mold was typically made of two hinged pieces of steel or brass. When closed, the inside of the mold had a cavity carved into the exact shape and size of the desired bullet. These molds were often designed to create 1, 2, or even a half a dozen bullets at a time. Before pouring the molten lead, the user would often smoke the inside of the mold with a candle. This thin layer of soot acted as a release agent, making it easier to get the finished bullet out without it sticking. With the lead liquefied and the mold prepared, it was time for the most critical step, the pour. The craftsperson would carefully and steadily pour the molten lead from the ladle into a small hole at the top of the closed mold. It was important to pour quickly and evenly to ensure the lead filled every nook and cranny of the cavity before it started to cool and solidify. A good, clean pour resulted in a perfectly formed bullet without any air bubbles or imperfections, which could affect how it flew through the air. Any extra lead that spilled over the top formed a little flat piece called a sprue. After pouring, the mold had to cool down. This didn't take very long, as the metal of the mold would quickly draw the heat out of the small amount of lead. Once it was solid, the handles of the mold were opened. Inside sat a shiny new bullet, still attached to the sprue. The final step was to trim this excess piece of lead off. A special tool on the mold itself, or a simple pair of snips, was used to cut the sprue away, leaving a flat base on the bullet. The freshly made bullet was then ready for use, and the sprue was thrown back into the melting pot for the next batch. While the process sounds simple, it was filled with hidden dangers that required a great deal of respect and caution. The most obvious hazard was the molten lead itself. We're talking about a liquid metal heated to over 600 degrees Fahrenheit or 327 degrees Celsius. A single misplaced splash could cause a severe burn that could leave a permanent scar or worse. People had to be incredibly careful, ensuring their workspace was stable and free from anything flammable. They also had to be mindful of water. Even a single drop of water falling into the molten lead could instantly turn to steam, causing a violent eruption that would send hot lead flying everywhere. Another interesting detail that many people don't think about is the quality of the lead. Not all lead is created equal. Pure lead is very soft, which was perfect for muzzle-loading rifles, where the bullet needed to expand slightly to grip the rifling inside the barrel. However, for other types of firearms, pure lead was sometimes too soft. Craftsmen would occasionally mix in other metals like tin or antimony to create a harder alloy. This prevented the bullet from deforming too much upon firing. This was an early, simple form of metallurgy done by trial and error right there by the fireside. A fun fact that highlights the precision needed involves the temperature of the mold itself. A common mistake for beginners was to pour lead into a cold mold. If the mold was too cold, the lead would start to solidify the instant it touched the metal surfaces. This would cause wrinkles and incomplete fills, resulting in a poorly formed, unusable bullet. Experienced bullet casters knew to preheat their molds by holding them near the fire for a bit. A warm mold allowed the liquid lead to flow smoothly and completely fill the cavity, producing a perfect, crisp bullet every single time. It was a subtle trick that made all the difference. Beyond the immediate danger of burns, there was a long-term risk that people of the time didn't fully understand lead poisoning. They were handling lead with their bare hands and breathing in the fumes from the melting pot day after day. We now know that lead is a neurotoxin that can build up in the body over time and cause serious health problems. The very material that was so essential for their survival was also a silent threat. This adds a layer of unseen danger to the romantic image of a frontiersman casting bullets by the campfire, a risk they faced without even knowing it. The era of handcrafting every single bullet eventually gave way to the age of mass production. The Industrial Revolution brought about powerful machines and new techniques. Factories could now stamp out thousands of perfectly uniform bullets in the time it took a single person to cast a handful. This standardization was a game changer. It meant that ammunition was not only more readily available and cheaper, but it was also more reliable. You could finally buy a box of cartridges from a store and be confident that every single one would fit and function perfectly in your firearm. The need for individual craftsmanship faded into history. Modern bullet manufacturing is a world away from a ladle and a mold. Today's bullets are made on high-speed automated assembly lines. Instead of being poured, most bullets are now formed through a process called swagging. This involves taking a piece of lead wire and using immense pressure to press it into its final shape inside a die. Many modern bullets are also jacketed, meaning they have a core of lead covered by a harder outer layer of copper or another metal. This allows for higher velocities and better performance. The science and precision involved are truly incredible, a far cry from melting scrap over a fire. However, even with all this advanced technology, the old-school method of casting bullets has not disappeared entirely. It has found a new life as a hobby for firearms enthusiasts, historians and do-it-yourselfers. For some, it's about connecting with history and appreciating the skills of generations past. For others, it's a way to create custom ammunition for antique firearms or for specialized shooting competitions. It's a craft that teaches patience, precision, and a deep understanding of how firearms work. The process forces you to slow down and appreciate the mechanics of what you are creating. In the end, learning about the old way of making bullets is more than just a history lesson. It's a story about human ingenuity and self-reliance. It reminds us that for a very long time, survival depended on what you could make with your own two hands. While today's bullets are products of incredible engineering, the simple, hand-poured lead ball represents a direct link to our past. It's a small, heavy piece of history that tells a story of campfires, frontiers, and the timeless human drive to innovate, create, and master our tools. That legacy is